sheet in the bottom, it says in the expansion of x plus y to the n. Okay? All we've really expanded so far at most is like x plus y cubed, right? And then we'd go like x plus y times x plus y times x plus y, and you'd have to expand that. And that's kind of awful. Well, we could now give you x plus y to the 10 or x plus y to the 12, which would mean you'd go x plus y times x plus y times x plus y times x plus y times 8 more x plus y's. And then you have to FOIL 4 times. Then you have to distribute, and then you have to collect like terms, and then you get x plus y to the 12, right? Super fun. No, not at all. So when you're complaining about the new formula that I teach you and how much that time it takes, remember how awful it could be, okay? So we aren't going to complain about this one. Over there is tk plus 1 equals nck x to the n minus k y to the k. Okay? And that will get you one term. Yeah? Now, as you complain as we use that, remember having to FOIL 6 times if you did like to the square, to the 12. Then you have to distribute a whole bunch more. And then you have collect like terms. How awful that would be, right? So this isn't too bad. You'll be okay. So a plus b to the 5 would actually be a plus b times a plus b times a plus b times a plus b times a plus b, right? Or we can expand it using that formula, okay? The key thing is that k is always 1 less than the term you're finding. Just keep that in mind. K is always 1 less than the term you're finding. There are always n plus 1 number of terms. This will make sense in a second. They also tell you in order to use that formula, that blue formula, it will say in the equation x plus y to the n written in descending powers of x, the general term is this. So it has to be in the form x plus y to the n. It tells you that. So this has to be in the form x plus y to the n. Okay? Then we can use that formula. So this is going to be x plus, this is going to be y, this is going to be n. So I know x equals a, b equals, y equals b, n equals 5. So if n equals 5, when I expand this function out, how many terms am I going to have? 6. We agree? We're going to have 6 total terms, yes? And the reason why that is when you expand it out, you start out at k equals 0 because you're finding term 1, and k is always 1 less than the term. So you start out at k equals 0, and you go till n. N is 5, right? So you're going to go k equals 0, k equals 1, k equals 2, k equals 3, k equals 4, k equals 5. How many terms is that actually then? 6. So that's why you get 6 terms. Okay? So term 1, term 2, term 3, term 4, term 5, term 6. Okay? If I have all the terms that I'm finding, what are my k's? For term 1, what's my k equal? 0. For term 2, what's my k equal? And then plus term 3, my k is going to equal. Plus term 4, my k is going to equal 3. Plus term 5, my k is going to equal. And then plus term 6, my k is going to equal right? Now we know n because it never changes. We know x and we know y because they never change. The only thing that changes every term is the k, correct? So we're now going to fill it into this formula here. We don't need this because this just tells you the term number. We're not going to deal with that. We're just going to replace this for each term. Okay? So term 1, n is 5. C, what's my k? 0 for term 1, right? X is a to the n minus k, so 5 minus 0 is my exponent. And then y, which is b, to the k, which is 0. Term 2 is going to look exactly the same, but what's going to change? All the zeros are going to become 1. In term 3, all the 1s are going to become 2s, etc. That's the only thing that changes, okay? So now we're going to get this equal to 5 choose 1. A to the 5 minus 1. B to the 1. Then term 3 is 5 choose 2. A to the 5 minus 2. I'm going to start writing really small. B to the 2 plus 5 choose 3. A to the 5 minus 3. B to the 3 plus 5c4. A to the 5 minus 4. B to the 4 plus 5c5. And you know you're done when you hit the same thing, right? Because we can't have 5 choose 6. That doesn't make any sense. A to the 5 minus 5. B to the 5. All right. 5 choose 0. If I have 5 things and I choose none, how many ways can I do that? It's kind of a trick question. There's only one way. You just go, hey, I'm not choosing you. And one way. Okay? 5 choose 0 is 1. Oh, I need my smaller. And then we have a to the 5, b to the 0. What's anything to the power of 0? 1, right? So it just goes away. This becomes a 1. So I'm literally left with a to the 5. I have 5, I choose 1. How many ways can I do that? 5 ways, right? If I have 5 people here and I choose 1 at a time, how many different ways can I do that? I can pick one person or I can pick the next, so 5. A to the 4, B to the 1, so B. Plus 5 choose 2. What's that? 10. A to the 3, B to the 2. Now 5 choose 3 is actually 10, and I know that right away. Why? Right, 2 plus 3. So if you go like this, 5 to the 2 is the same as 5 to the 3 because the difference between them, remember that rule I told you? So they're going to be the same. 10, A to the 2, B to the 3, plus, now 5 to the 4 is the same as 5 to the 1. So 5, A, B, 4. And then 5 to the 5 is the same as 5 to the 0. So 1. This cancels to a 1. B to the 5. And you're done. Now I know that may seem a little crazy, but think about having to expand a plus b times a plus b times a plus b times a plus b times a plus b out. You're probably going to make a mistake somewhere, and you'd have to collect a whole bunch of like terms, right? Make sense? Yeah. Because if you have 5 at most, you can choose 5. Yeah. So that's why you always end up with one more term than n, because you start at k to the 0 and you work up to n, right? So you always end up with one more term. B. There's a change with B in the fact that I told you off your formula sheet here, it said it has to be in the form x plus y to the n, correct? This one have a plus sign? No, but we can make it have a plus sign. So it would be 3a plus -2 to the 4. So y is not 2, y is actually -2, right? So you have to remember to do that because they're going to have the answer to y being 2. Yeah? That's going to be common error. So this is my x, this is my y, this is my n. So x equals 3a, y equals -2, n equals 4. K changes per term, right? So it's one less than the term number. Now, my question to you is, how many terms is this going to have? How many different terms is this going to have? 5. Yeah, one more than n. So it's going to have 5 terms total. And why is that? Because we're going to start at k equals 0, and we're going to go up to n. N is 4, right? K equals 0, k equals 1, k equals 2, k equals 3, k equals 4. How many terms is that? 5. So it's always one more than n. Okay? So, term 1, k equals what? 0. So it was one less. Plus term 2, k equals 1. Plus term 3, k equals 2. Plus term 4, k equals 3. Plus term 5, k equals 4. And I have to stop there because n is 4 and I can't choose more from something that doesn't exist. Okay, now we're going to fill it into the formula. So, n 4 equals 4c0 x, which is 3a, to the 4 minus 0, y, which is -2, to the 0, okay, plus 4, choose 1 this time. All the zeros are going to become 1s. 3a to the 4 minus 1, -2 to the 1, plus 4, choose 2, 3a to the 4 minus 2, -2 to the 2, plus 4c3, 3a to the 4 minus 3, -2 to the 3, plus 4c4, 3a to the 4 minus 4, -2 to the 4. This one's harder than the previous one because actually the a and the b, or the x and the y, sorry, have coefficients. They have numbers in front. So those exponents are going to affect the coefficient as well. So 4, choose 0. How many ways can I have 4 and choose none of them? The lowest amount of ways you can ever do it is 1, so it's 1. It's going to be 1. And now this is going to be 3a to the 4 minus 0. The error they're going to have is people forgetting to apply that 4 exponent to the 3 as well. So I'm going to show that step in between here. So we're going to get 3 to the 4, a to the 4. Because that exponent to 4 has to go to both of them. Do you see how you could forget to put it to the coefficient? Yeah. And then -2 to the 0 cancels. Plus 4, choose 1. How many times can you have 4 and choose 1? 4 ways. Then you have 4 minus 1, which is actually 3. So we're going to get 3 to the 3, a to the 3. And then -2 to the 1 is -2. Plus 4, choose 2, 6 ways. And I know this because look at Pascal's triangle. Whenever this is going to get us 5 terms, so we go to Pascal's triangle here and we get 1, 4, 6, 4, 1. That's going to get me the 4, choose 0, 4, choose 1, 4, choose 2, 4, choose 3, 4, choose 4. That's why Pascal's triangle is good. But you're already filling it in anyway, so to me. So we get 6. This is 2. So we're going to get 6, 3 to the 2, a to the 2. And then -2 squared is 4. Remember when you put a negative into your calculator, if you're going to put this into your calculator, you have to put a negative in brackets. If you go negative 2 squared in your calculator, not in brackets, it'll tell you the answer is negative 4. When you square anything, that's like negative 2 times negative 2. What's a negative times a negative? A positive. So any negative to an even exponent will be positive. Any negative to an odd exponent will be negative. But if you don't put it in brackets in your calculator, it'll tell you it's negative every single time, which is not true. So if you went negative 2 squared in your calculator, not in brackets, it treats it as negative 2 squared. 2 squared is 4, so it's negative 4, which negative 2 squared is not negative 4. Negative 2 squared is positive 4. Plus 4 choose 3, which is 4, because it's the same as 4 choose 1. 3a, because it's just to the 1. And then negative 2 to the 3 is negative 2 times negative 2 times negative 2, which is negative 8. 4 choose 4, you choose them all one way. This is to the 0. Anything to the power of 0 is 1, so it cancels. Negative 2 to the 4 is negative 2 times negative 2 times negative 2 times negative 2, which is positive 16. Now, the last step is to take every coefficient, multiply them together, and put it in front of the variables. Okay? So we have 1 and 3 to the 4. 3 to the 4 is 81. 1 times 81 is 81. And then we write any exponents behind, so a to the 4. Plus, now we're going to go 4 times 3 cubed, which is 27, times negative 2, because those are all coefficients. So what's 27 times 4 times negative 2? Negative a cubed. Would we ever write plus a negative together like that? No, we would just write it as negative, right? Then we have plus 6 times 4 times 9. 24 times 9. What do you get? A squared. What's 4 times 3 times negative 8? So 12 times negative 8. Negative 96. A plus 16. On the diploma, they don't most of the time make you expand a whole thing, okay? Which is time consuming if you have to do every single term. What they'll do is they'll ask you to just expand a certain term most of the time. So let's flip to the next page. So, like this one, find the fourth term. Worst thing you could do here is expand it all out and then give me the fourth term. That is way too much time. If it says fourth term, remember in every single term, what's the same? X, Y, and N. What's the only thing that changes from term to term? Your K. And our K is really easy to get if we know what term we're finding, because our K is always what? 1 less than the term. Because if you can't remember if it's 1 more or less, which confuses people, if you're finding term 1, K is what? 0. So K is 1 less. If you have to think of it that way, then you can move on and think of it another way. That's fine. But so the fourth term, if the first term K is 0, the fourth term K is 3. How many total terms does this one actually have if I expanded it all out? 9, because it's always 1 more than N. So this would actually have 9 total terms. So let's find the fourth one. Remember, the hardest part of this is if there's a subtraction sign in the middle, you have to remember that that joins your y, and you put a plus sign in between the two terms. Yeah? So this one doesn't have one. So our x is x, our y is y, our n is 8, and our k is 3. This will be way easier. So we go, our formula is n, c, k, x to the n minus k, y to the k. So we're going to get 8c, 3, x to the 8 minus 3, y to the 3. What's 8c3? 56. X to the 5, y to the 3. correct? You try 2 and 3. So this one is going to be 2x plus negative 5 to the 7. So this is your x, this is your y, this is your n, and we'd have 8 terms total if they asked us that. Different color. They want the third term, so we know k equals 2. So we're going to do 7c2 x, which is 2x to the 7 minus 2, negative 5 to the 2. What's 7c2? And then we're going to get 2 to the 5, x to the 5 times 25. 2 to the 5 is 32. 21 times 32 times 25. 16,800. X to the 5. Now the middle term is often hard for people to figure out which it is. So all I do is write out all my k's and then pick the middle k. So I know I'm going to start out at k equals 0 and I'm going to work to k equals 10, correct? So k equals 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I want the middle k. So 1 for 1. I'm going to take these ones. I'm going to do these ones. I'm going to take off these ones. I'm going to take off these ones. And k equals 5. You can go like term 1, term 2, term 3, term 4, term 5, term 6, 7, term 8, term 9, term 10, term 11, and then it would be term 6, which is k equals 5. You could do it that way too. You could do it as k's or terms. Doesn't matter. So we're going to get 10c5, a to the 10 minus 5, b to the 5. 10c5 is what? 232? 252. A to the 5, b to the 5. Okay? 4, 5, and 6, and 7 make it a little harder. So we're going to do those ones tomorrow at the beginning of class. I'm also going to hand out that booklet with all of the diploma style questions. And you're going to do them over the weekend. And on Monday, we're going to go through them. If you don't practice them, we have seen perms and comms can be great or awful. They can make you happy or cry. So practice them and you'll do really well on them. I'm going to give you the homework to the